Alright, now we're going to talk about squares. So, when we look at squares, first of all, I think we all know a lot of things about squares. But we have a lot of things that we have to actually go through and mark. So it makes it look a little bit more confusing, but there are lots and lots of things we know. So, when we go through and do this, we're going to mark them. It says opposite sides are congruent. Now, one thing that we do know is actually that all the sides are congruent. All right. And then we have opposite sides are parallel, so we can mark that. And then it says these opposite sides, well, this is the most specific type of quadrilateral. It's got all the stuff going on, which is surprising, makes it a little bit easier. So it says consecutive angles are supplementary. We don't have anything for that. Diagonals bisect each other. So here's our diagonal, and here's our diagonal. And they cut each other in half. Okay? 1, 2, 3. 1, 2, 3. And actually what we have here is it says diagonals are also congruent. Right here that they're congruent. So that means that these are actually all the same exact size. Whoops. They're all the same exact size in the middle. Alright? We have 4 right angles on the outside. Okay. And we've got right angles on the inside. And we have that diagonals bisect opposite angles, so that means that this 90-degree angle is cut directly in half, meaning that every single one of these angles is exactly 45 degrees. So in a square, it's kind of nice. You're either 45 degrees or you're 90, so that's pretty nice. Now, what you should also recognize, as I'm putting this in here, is that we now have a bunch of 45, 45, 90 triangles. So we can actually use that knowledge from our special right triangles in order to save ourselves some time. So, when we go through and look at our example, we have if ABCD is a square and AD is 11. So as soon as you know that it's 11, we can put all of our side lengths as 11. Alright. Now, there are multiple ways to go ahead and get any of the interior sides. So let's see what parts they ask us for. So BC is 11, we've already marked. AC, so if they want to know this entire thing, one thing that we do have is we know right here that we have a right angle. And I'll go ahead and make it purple, but when we go like this, we actually have a 45, 45, 90 triangle. So we're just looking for the hypotenuse of a 45, 45, 90. So if you can remember, we have our pattern for 45, 45, 90. It goes 1, 1, square root 2. So we already have 11 and 11. So we'll put 11 here and 11 here. And we want to know that hypotenuse. So what we do is we cross multiply. So we have 1 over 11 equals the square root of 2 over x. So let's cross multiply and we get x equals 11 square root 2. So all the way from A to C, that's this part right here in blue, is 11 square root 2. Alright? Then they ask us for BD. So knowing that these are exactly the same size gives us 11 square root 2 for the second one. So both of our diagonals are exactly the same. Then we have EC. So EC, actually, we want to go through and take half of our diagonal. So our diagonal was 11 square root 2. And since 11 is not divisible by 2, you can actually just write 11 square root 2 over 2. If it was divisible, we would just divide that front number by 2. Alright? Now we're going to look at angle DAB. So DAB is one of the corners here. So one of the corners measures 90. In fact, every single one does. AEB, there are right angles in the middle as well, so we have 90. Then we have CBD, that's just part of or half of 90. So we have 45. And then we have BAC, which is again part of or exactly half of 45. I'm sorry, of 90, which is 45. All right. Now we have for number 2. Number 2 says if STUV is a square. It then says SW, that's this part right here, is 2x plus 13. And it says WU is 8x minus 41. What do you know about the two parts of a diagonal? Correct. They're exactly the same size. So because they're exactly the same, we set them equal. Alright, now let's plug it in, or let's go through and solve. So I'm going to subtract 2x and get 6x. And I'm going to add 41. And if I add 41, that gets me 54. And then I divide by 6 and I get x equals 9. Now I just need to decide, how do I find what VT is? So VT, one thing that I could do is I could plug in to one of them. So I think 2x plus 13 looks pretty easy. And then I just need to double it. So 2 times 9 plus 13. That gets me 31. And then I need 2 of them, so times 2. So VT equals 62. Perfect. Now let's go through and look at number 3. So remember I told you there are only 90-degree angles, or there are 45-degree angles in the square. So here we have just part, meaning that this is 45. So we're going to do 7x plus 3 equals 45. And we're going to solve. So subtract 3 and you get 7x equals 42. And then you divide and you get x equals 6. And that's all they ask of us. So we're done. Alright, now let's look at the last one. So it says PR is 17. Which means I know that this one is 17. I know that this one is 17. And that one is 17. So I have 2 different options for how to solve this for our other side lengths, or our exterior, or like our outside part. So here, I'm just going to highlight this little triangle. It's not the only one I can look at, but I'm going to highlight it and use it. So again, it's a 45, it's a 45, 45, 90. So I have 1, 1, square root 2. And my 2 smaller ones are both 17. Alright, and then I just need to find the last one. And the last one is our hypotenuse, so we'll put an x. And then we'll solve. 1 over 17 equals square root of 2 over x. And then I'm going to cross multiply, and I get x equals 17 square root 2. And that belongs on all of our outsides. So this belongs 17 square root 2, 17 square root 2, 17 square root 2. And our last one, 17 square root 2. Now we'll go through and fill everything out. So PR is going to be 2 of our 17s, that's 34. QS is also going to be the same size, so 34. QT, we went through and we found, so QT is an easy one, that one is 17. We already have it labeled. PQ is one of the sides, that side is 17 square root 2. Now for the angles, whenever I have a square, I just go through, I see, is it the big one or the small one? Is it right or is it not? So PRS is not a right angle. It's right here. So it's half. So that's 45 degrees. And then I have STR. That one's in the middle. It is 90 degrees. PSR is in the corner, which makes it 90 degrees. And then QPR. QPR is right here, or part of, so it's 45 degrees. So squares are probably our easiest one, but we've got to have all of these things memorized. Alright, so those are our squares.